Hello. So during the very first lecture, we discussed what econometrics is and what econometrics is used for. But actually during upcoming semester, we are going to deal with numerous mathematical and statistical concepts. And based on my experience during the first year of MA studies, students have very different background regarding math and statistics. So this lecture is a kind of a crash course when we are going to discuss the most relevant, important, and complex ideas from math and statistics. We are going to use a lot during the course. So we will start with the simplest one, which is average value. And basically, average, mean, or expected value are the same, but they are used in a bit different context. So we usually say average when we analyze small samples, mean in the context of big samples or population, and expected value in the context of distributions. And in a second, I will show you how to calculate it. So in this table, we have 7 students and their grades for Introduction to Econometrics subject. And we want to calculate the average grade for this group of students. So usually we use, not usually, always, we use this formula. I just wanted to say that usually we use mu in order to denote mean or average value. So first what you have to do is to calculate the sum of all the values of variable x. In our case, it's grade. For all the students. So this index basically denotes index of a student. So for instance, x1 is equal to 60%. This is the grade of the first student. x3 is equal to 20%. This is the grade of the third student. So we have to calculate the sum, and we have to divide the sum by the number of observations, number of students in the group. So in our case, calculations are not that complicated. We just have to sum up all the values. So I would like just to add that in our case, percent is a unit. So that's why we do not include it to our calculations. Because you can, but I believe that with, without decimals, it's much simpler. Then you divide by the number of students, and you should get 50.86, which is approximately equal to 51. Because we are going to use the mean value in the further calculations, and I would like to make things at least a bit simpler. Okay, so the average grade in the group does not tell anything about the distribution. So it's possible that all the students have 51, and it's also possible, like it is in our case, that half of students are really good and some of students are really bad. So in order to assess this, we usually use variance and standard deviation. So those are two typical measures of dispersion. Typically, large variance indicates big distance between values and the mean value, and big distance between the values. In our case, large variance would indicate that students have very different academic performance. And low variance means that values are relatively close to mean and themselves, and in our case it would mean that students have relatively similar academic performance. And standard deviation is calculated as the square root of variance. So let us try to calculate variance using the same data set. And the general formula is like this: sigma squared. So usually sigma denotes standard deviation, and standard deviation is the square root of variance. That's why variance is equal to sigma squared. So in order to calculate variance, first you need to calculate the difference between the value of each variable and the average value of the variable. Okay, probably I messed up a bit with the notations. So x here, this variable stands for the mean of x. So this is what we calculated before. So first you need to calculate the differences between the value of variable and the average value for each of those observations. And then you have to take each value to the power of 2. And this is due to the fact that we are not interested in the direction of this difference. So this difference can be positive if student I performs better than average, and it can be negative if student I performs worse than average. But for us it makes no difference. We are just interested in the absolute value of this difference. That's why we take it to the power of 2, because whatever you take to the power of 2 becomes a positive number. So then we have to calculate the sum. And finally we have to divide this sum by the difference between number of observations and 1. So we shall start with calculating the distance for each of those variables. For each of those students between student's grade and the average grade. So as you remember, our average value was 51. So in our case, 60 minus 51 gives you 9. Then you have -6. Okay, actually you do not need percent here. We just take, as I told you, we take percent as some unit. -6, then we have -31, 5, 24, 39, -41. So we made those initial calculations, and now we can apply this formula. So first we calculate the sum of squares, and this shall be equal, okay, first I will just write it down. So 9 to the power of 2 plus -6 to the power of 2 plus -31 to the power of 2 plus 5 to the power of 2 plus 24 to the power of 2 plus 39 to the power of 2 plus -41 to the power of 2, and we divide this by 7 minus 1. Probably there are too many steps, but I just want everything to be perfectly clear for you. So then when we calculate those values, so then when we calculate those values, we can add them up. So there will be 81 plus 36 plus 961 plus 25 plus 576 plus 1521 plus 1681, and divide this by 6. So our variance would be equal to 4881 over 6, which gives you 813.5. So typically variance is larger than the mean value. So that's why, in order to make it more comparable to the mean value and to the grades of students, we can calculate standard deviation. So this is a square root of variance. It's square root of 813.5, which is approximately equal to 28.5. So this is variance and this is standard deviation. As I told you, you can see that it's like more comparable to those values. Like you can interpret this as a standard error, like average difference between average grade and performance of the student, but more sophisticated, of course. Okay, so that was it when it comes to mean, variance, and standard deviation. In the next video, we are going to analyze covariance and correlation, which are always about relationship between two or more variables. So thanks for your attention and see you in the next video.